But I just wanted to thank Blowman, whoever Blowman might be. Thank you, Blowman, because if Blowman would not have made this post on the VESC forums, Blowman showed me the way, and he showed me the light and the power of VESC scripting. So let's take a look at this. Guys, welcome back to the channel. Welcome back. So we are doing some VESC stuff. So the other day I was playing around with the pedal assist functionality, the pedal assist system that exists within VESC currently as of June 22nd, 2024. So VESC is an open source project for electronic speed controllers and motor controllers. So we can use VESC controllers with our e-bikes. And recently I've been using the Flipski 75100 Pro V2 controller. So it's a VESC based controller, works up to 72 volts. It's a very powerful controller. If you're going to buy a Flipski, use code EBB at flipski.net. You save $10. There's also the Flipski 75200, so that one's more powerful, for like a more powerful motor. But anyways, we've been using the Flipski. I was trying the pedal assist system that exists within VESC currently, and I was kind of having problems with it. It seems a little bit rudimentary. It's how it works is it's like Sonic how I described it was Sonic the Hedgehog pedal assist, where like the faster that you pedal your legs, the more power pedal assist gives you. So if you're just pedaling slow, you're just getting a little bit of power. But then if you start pedaling fast like Sonic the Hedgehog, then pedal assist goes fast. And that was interesting to me. I've never seen a pedal assist that works like that before. So, and that's just like that behavior, how it exists within VESC right now. That's how it is. And if you want to change that within VESC, you would have to download the source code. You'd have to set up a development environment. You'd have to sit there and change all the source code and compile a custom firmware, and then upload that custom firmware onto your controller, your VESC controller, and get that firmware on there. And then as long as it was all working properly, you could implement like a really good pedal assist system however you want, right? Because you got the source code for the firmware, you're compiling that straight onto your controller, so it's like you're writing C code and getting that onto your controller, and that is controlling your motor. So that's really low level, that's more advanced, it's more difficult. Skill level is a lot higher. I don't even know if I could do that, to be honest. I haven't coded C since I was in like school. So it's a very low level language. Um, most people aren't coding in C nowadays. Most stuff is a lot higher level programming languages. So that's just not something that I'm used to. I probably wouldn't be that great at it. It would be very time consuming, very involved. Um, so modifying the source code, probably not something that I'm qualified to be doing anytime soon. I mean, like if I was really motivated, possibly. But the other option that seems very possible so far that I've been exploring lately is there's this scripting within VESC that you can use. And so this is completely new to me. I've never, I guess it's based on a programming language that's called Lisp or something. So VESC, so this is what happened. I went on to Google and I was searching around for pedal assist in VESC. It seems like there's a system that exists already. We tried that out in my previous video. It's the Sonic the Hedgehog one. And that's just not desirable. So then I found this other thread on the internet. Right here. So I want to thank... So this thread, this is one of the very few threads and very few resources that I have found about how there's the possibility of changing pedal assist with scripting in VESC. So it's just some random, one of the very few posts on the VESC forum about pedal assist. And so they're talking about like customizing it, and then so down here there's this guy, Blowman. So Blowman, I want to thank Blowman because he led me down this scripting path. And it seems like it's going to work. So Blowman, he shared a script on the forums. He says, here's my code implementing pedal assist. So it's a script, and you use the desktop version of the VESC tool to save these scripts to your controller. So you got to get the VESC tool on a desktop computer. It's got to be on Windows. Like, it just doesn't work on Mac. I've tried. Just trust me. Don't bother with the VESC tool on Mac. All right, you need Windows. And it's got to be the computer for this. I don't think you can save this script. I mean, how it works is you get onto the VESC tool. Once you get connected, whether it's Bluetooth or USB or whatever, we can do these scripts. And I've been working on one. So I want to show you what I've been working on with this script. And how I'm going to try to get pedal assist working better in VESC. So we're going to do it with a script, boys. So let's make me go smaller here. Alright. So I've been working on this script in this Lisp VESC scripting language. So, okay, so after I came into the VESC tool and I got connected, whether it's Bluetooth or USB or whatever, TCP, however you want to do it, I can't help you with that, but you just got to get connected. And then you come down here on the left to VESC Dev Tools. So we click down here on the left, VESC Dev Tools. And then it might come up with this or something first, but then you come over here to Lisp. Click on this tab right here. See my mouse? Lisp. And then it's got this big, it's gonna probably be like empty like this. Right? But you can write scripts in here. So this is scripting. Alright, so over here we can come to a new tab. We can make a new tab where we can write scripts. Right, but I've already got a tab here. Right, so when we have a tab and then we save it down here, we save that script into a file. So you can see down the bottom right when I hit save, it'll say saved, and it'll show you where on your hard drive it's saved to. Okay, so lately I've been working on this script that is gonna run the pedal assist on my flip ski. So I want to show you, and so right now it's not spinning the motor or doing anything. What it's doing is it's reading my pedal assist sensor, and then it's figuring out if the pedaling is going forwards or backwards. And then what I want to have the script do is when I start pedaling forwards, I want it to start the pedal assist. And then if I start pedaling backwards, I want it to do regen braking. And I think what I might do is, so when I'm pedaling forwards, I just want it to be like normal cadence sensor pedal assist. So it just gives me, as soon as I start pedaling, it's just giving me a certain amount of power, certain amount of current. And then I'll just change that amount of current wherever, whatever. You can change it. You can change the max current in the VESC tool using the app. So you can limit the max watts. You can limit the current in the VESC tool app on your phone. So, I mean, I think you could just make pedal assist do maximum current in the script. And then on your phone, you can just limit the maximum current to limit the pedal assist current. So we're just starting out basic. Let's basic scripting. We're seeing what's available in scripting in VESC. So I want to run you through this script that I've wrote so far in VESC and show you how it's working. Let's take a look at this script. So in this script, can I make this bigger at all? I don't know if we can make it bigger. Oh. 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 Oh, this is like the Windows magnifier. Let's see here. Can we zoom out a little bit? Here we go. Whoa, 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 whoa. Alright guys, so I've got this script that I've been working on that's going to run the pedal assist. So this is like a script that we're writing with this Lisp scripting language that's available in VESC. So let me show you what it's doing so far. So in the script, so I define some variables for like how many magnets my pedal assist sensor has. Let's zoom in on this a little bit. So I define some variables for like how many magnets my pedal assist sensor has. So then, depending on how you wire up the pedal assist sensor, there's two wires with these quadrature pedal assist sensors that can detect going forwards or backwards. So depending on how you hook the pedal assist sensor up to the flip ski, the order of the two wires, you might have to invert that signal so that that it's reading forwards pedaling as forwards and backwards pedaling as backwards. So I've got a thing here where we can invert that if we need to invert the pedal direction. So then I've defined a variable. So this is the pedal assist timeout seconds. So that's kind of like when pedal assist is going and then you stop pedaling, how long should it wait as like a timeout before stopping pedal assist? So, like if you're pedaling, 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 and then you stop, and then there's no magnet pulses on that pedal assist sensor for this long, it'll stop pedal assist and time it out. Right? So I have that set to half a second. So you might even, if you wanted to be more responsive, could possibly make it lower. But just for development purposes, right now I've got it low. So then I've got a pulse threshold. So when the pedal assist sensor starts moving, it'll do pulses, right? But you can't really know for sure that the pedal assist sensor is moving in a certain direction significantly until it does a certain number of pulses so that you're a little bit more confident about it. So I was trying it with 2 pulses and it seemed like sometimes it was a little bit funny. It seems like every full rotation of my pedal assist sensor, it gives me a negative pulse, like a reverse pulse for some reason. I don't know why that is. But so I've got some stuff here. So we've got some variables here that keep track of the state of pedal assist. And then basically like what I'm doing is I've got this script that we can run on the flip ski in a loop. Right? So I've got a main loop here. And this is just like an endless loop. This stuff inside of here. So what it's doing so far is just the loop is very simple so far. It's just gonna update the pedal assist state. It calls that function, and then it sleeps for what is that, 100th of a second. So this loop should execute like 100 times a second. And then what the loop does and update pedal assist state in that function, that's kind of what's happening. This is going to happen 100 times a second. It's going to call this function from that main loop. And what I'm doing in this main loop is so we can read that RX pin. You know how I connected my pedal assist sensor to the RX and the TX pins on my flip ski? So those are just like 2 input ports, or I don't know what you call them, but it's just 2 wires that you connect to the flip ski. So there's 2 wires for my pedal assist sensor, and I've connected them to the RX and the TX wires on the flip ski. And so this is how I can read from those wires this is how I can read those signals that my pedal assist sensor is sending to the flip ski through those wires. Right here, right? So this right here, this is reading from that RX pin. So GPIO read pin RX, so that's reading the voltage, or it's reading that pin. So there's kind of, it's right. So we read the RX pin, we read the TX pin, so then we've got those. And so this is happening constantly, really fast. And so I've got a little bit of logic here, like if we're inverting the pedal assist direction, I'm just kind of like flipping some bits around and stuff that I use later. So then here I'm detecting rising and falling edges on the pulse. So the pedal assist sensor, how it works is there's magnets in a circle, and when you're spinning the cranks in a circle, every time a magnet passes the pedal assist sensor, it gives you a pulse, right? So cranks are spinning, and you're boop, 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 right? So then from the frequency of the pulses, we can know how fast the pedaling is happening, right? And then from the sequence of the pulses, since we have two wires that our pedal assist sensor is a quadrature pedal assist sensor, it's got two wires, and I think it's two signals that are 90 degrees out of phase. And so you can look at the pulses in those signals and compare them to each other and figure out, did the pulse just begin or did the pulse just end? So this is basically just some code that I figured out to kind of, it runs very fast, like 100 times a second, and it's waiting for a pulse, and then it kind of keeps track of those two, the RX and the TX, and then how they're pulsing, and it's parsing that. There's scripting here that parses that information and determines, are we pedaling forwards, are we pedaling backwards. I haven't wrote the code yet that determines the crank RPM, but that's the next step that I was going to work on. So maybe at the end I'll show you here how I write a little bit of code and I can calculate the crank RPM. For now, I just want to show you what I have so far. So basically, yeah, we're reading those two wires, the RX and the TX, and the information that's coming, the signals coming over those wires. So then down here, there's a little bit of scripting to detect when pedal assist times out and when the brake times out. So like I said, when I'm pedaling forward, I want it to do pedal assist, and then when I'm pedaling backwards, I want it to do the brake. So that's what I've been working on in the script. And I've got it working pretty good. So then the rest of this, let's see what else I have up here in the script. So that pulse detected function, that's what we were just looking at. So basically, like, it's got this loop, and in the loop, it calls update pedal assist state. Update pedal assist state, it reads the signals from those wires, and it has a bunch of logic to figure out what is happening with the pedal assist sensor from the state of those signals. Then up here we've got some more code. So when we do detect a pulse, so we're kind of looking at a signal and it goes from 0 to 1 and then back to 0. So when the signal changes from 0 to 1, that's kind of like the, what is it called? So that's the rising edge on a signal, is when the signal first, when it goes from 0 to 1, that's the rising edge of the signal, of like a square wave signal. And then when it goes back down to 0 from 1, that's like the falling edge, right? And then however, so we can calculate from the pedal assist sensor how fast are they pedaling, and are they pedaling forwards or backwards, right? So that is what I have done so far with a VESC Lisp script. And I want to show you here. So we're in my script here, and so what you do, you write your script here, and then you can come up here and you hit upload, and then hopefully, if everything works out, it'll say parsing blah 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 characters, however many characters are in your script. And then, so I've got some like debugging messages happening here. But so I've got my bike over here. And so so my script is running. So when you click upload, that uploads this, it saves the script onto your controller. And then the script is just going, right? So then it's got my loop running on my controller on the flip ski. And it's running this script, and it's calculating things and doing things and reading those signals from the wires. So if I go over to my bike and I start spinning the pedals, I've got messages. So let's clear all these messages. So I've cleared all that off. My script is running. So I'm going to go over here, and you guys will be able to see. Let's maybe move me a little bit here. Let's see. All right, so I'm gonna start spinning the pedals, and I'm just gonna talk. I'm gonna talk you through it. What I'm doing over here, you're not gonna be able to see the pedals. Oh. So I've got the chain off of my bike, so I can just spin the pedals forwards and backwards without needing to like actually move anything and have a chain stuck and a wheel stuck and everything. So. Okay, so as soon as I start pedaling forwards, look in the console, and you can see I've got messages being printed out, and so I'm pedaling, and saying forwards, forwards, forwards. See that? So that's my script that's printing those messages out, and then I'll stop. Okay, so it said pedal assist timeout, and then pedal assist stop, right? So, let me zoom this in a little bit here so you can see what's going on a little bit better. Let's see here. So can we zoom in? Okay. All right, I just zoomed it in a little bit so you guys can see what it's saying a little bit better. But so I'm going to start pedaling backwards. So you can see it says pedaling detected backwards, 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 backwards. Now I'm going to stop pedaling backwards. So it says brake timeout and brake stop. So like I said, when I pedal backwards, I want it to do the regen. So when it says brake stop, it's just going to stop the regen, right? So I start pedaling backwards, it says brake active, and then brake stop. So now if I pedal forwards, it's saying pedal assist active. So pedal detected, so see forwards, forwards, forwards. So it's detecting those pulses from the pedal assist sensor, and then it's starting pedal assist when I'm pedaling. Right, so pedaling, 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 stop pedaling. So then I'm going, so reverse, so now I'm going backwards, so brake, 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 stop. Pedaling, 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 stop. See that? So, theoretically, we have a scripted pedal assist system that is it's getting there, guys. It's getting there. We're going to get this figured out. We're going to get a script going that implements pedal assist in VESC. It's going to be pretty sweet. I just wanted to show you what I've been working on so far. I'm pretty proud of this, actually. Like, it took me, man, it's Saturday. I've been doing this all day, and I was doing it all day yesterday. So, yeah, I've been going for a few days on this VESC Lisp scripting, guys, and figuring this out, but I'm pretty stoked. We got this thing, like, I've got, like, the skeleton of a pedal assist system working here with the script. It's not actually, like, moving the motor yet or doing anything. This is all just, like, in theoretical logic, like, debugging messages land. But it seems fairly easy to, like, set the motor power just through the script and, like, set the regen brake and, like, turn the motor on and off and turn the regen on and off. So I don't think it's going to be hard to get pedal assist working with a script. So I just wanted to show you guys how cool this is and how excited I am about it. So let me know in the comments, guys. What do you think? What do you think about this little pedal assist script that we're working on here? And then, oh yeah, so there's debugging tools. So I want to show you the debugging tools. Let's get me out of the way. I'm just like sitting in the dark anyways. So let's see. So let's go back over here to the thing here. So okay, get that all the way. All right. So yeah, there's some other cool stuff in this scripting tool is sweet. This scripting tool is awesome. So everybody should go donate to the VESC project or donate to Benjamin Vetter, because Benjamin Vetter is the bro that made this thing. So this is sweet. So look over here. Look over here. So let's get these. Let's get. So over here we have a little like debugger thing. So like right here. So let's see if I can zoom it in. See right here, seconds since pulse. So that is one of my variables that I have in my script, and it's showing it over here in the debugger. So look, it's 180 seconds since the last pedal assist pulse. So if I come over here and then I start pedaling, it should reset that back to 0 since it got a new pulse. So watch this. Oh, oh. See, there you go. Reset it. So if I pedal it again, zoop. So that's kind of cool. All right, guys. Well, let's see here. All right, guys. Well, I'm going to get back to working on this script and figuring out how we can get pedal assist working in VESC. But so far, it's pretty cool. And I think we can do what we need with scripting. So let me know, how should pedal assist work? How should I make this script work? Do you like back pedal regen? I've never tried it. Never tried it. I know that it's a thing that you can do on the Grintech Phase Runner, and Justin talked about it in his talk a little bit, so I want to try it out with the script. But let me know, how should I make this pedal assist script work? What's your ideal pedal assist behavior? Like, how would it work? How much would you have to pedal for it to kick in? And then how much power do you like pedal assist to give you? So do you like just cadence-based pedal assists, where you just no matter how fast you're pedaling the cranks, as long as you're kind of pedaling them, it's giving you power? Or do you like that Sonic the Hedgehog thing? Let me know, guys. How should I make this script work? We'll get this thing sorted out. Right now it's not doing anything, so I'm not going to like share the script yet. But as soon as I get something that I feel is working to some extent, and it's like usable, I'll share the script with all you bros, and we can all script in VESC Lisp together. So make sure you guys like and subscribe. It's midnight. I'm getting tired and loopy. I'm getting a little bit goofy. But I was just excited about the scripting, so let me know, guys, how should I make this script work? What do you want to see this script do? Like and subscribe. Thanks for watching. I'll update you guys as soon as I develop this thing further in the Lisp scripting within VESC. Thanks for watching. Peace out. Have a good weekend.